Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust and trying to learn Rust in between. I'm Eugene. We have, where are they?
Luciano, hello.
Roberto.
Sorry, had a tough time finding there. Thank you, everyone, for joining and following along. If you never did Advent of Code, it's a code challenge that is published every year in December around Christmas. There's one going on right now. We are currently working toward last year's one. There's 24 challenges. You can find them on adventofcode.com. And I presume there's a banner. There it is. And we are publishing all of our code on GitHub. And you can obviously check it out there. We also publish these. Sorry, we have a YouTube channel where we publish these recordings. You can find that as a link in the description of the Twitch channel. If you're watching this on YouTube, there's a link to the Twitch stream in the YouTube channel description. So we are going to do exercise 24, part 1, I think, today, right? And Roberto is driving.
Yes, let me share the editor. So, day 24. The usual story. You arrive with your raft, you are in a lobby. This lobby has hexagonal tiles. Every tile has 6 neighbors: east, southeast, southwest, west, northwest, and northeast. The direction are given in a list, like this sample input. So southeast, southeast, northwest, northeast, 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 west, southeast, east, and so on. When you identify a tile, you flip it. If you land on a tile from white to black, or from black to white, you flip it. Because the tile is on the side white, on the other side black. If you land on on a tile that it was already flipped, you flip it again, so it go back to the previous state. In this above example, after this amount of tiles that are flipped, 10 tiles are flipped, 5 more are flipped twice to black, and then from black to white. After all of these instructions have been followed, a total of 10 tiles are black. Now, we have to go through our input that I can show in a moment. That is this one. So, a lot of instructions, one per line. Part 1 is asking us, after all this flipping, how many tiles are left with the black side up? Our answer is 523. To explain this better, I can share a slide. Yeah? What do you think, Luciano?
Yeah, go ahead. I will add it to the stream.
Just a second. This one. So, sorry. Okay. So, our tile is hexagon, so 6 edges: the east, west, northeast, northwest, southwest, and southeast. They are all together packed because hexagons can pack nicely, like squares. The coordinate system is handy to use is, okay, we have a 0, 0 tile. Obviously, this all is infinite, like always. Hypothetical all with infinite space. If you go east, you go x plus 2, y stay the same. If you go west, x minus 2 and y stay the same. If you go southeast, plus 1 plus 1. If you go southwest, minus 1 plus 1. If you go northwest, minus 1 minus 1. If you go northeast, 1 minus 1. So if you have a command that tell you start from 0, 0, you go southeast, and then you go northwest, basically you are going in a direction, coming back, and you are still in 0, 0. So in our input, different commands can flip the same tile, because you can arrive on the same tile through different paths. So our first part is to be able to tell how many tiles are on the black side.
After having processed all the input, right?
After having processed all the input, that is quite a lot. That is way more than 500 lines.
Technically, every line is flipping one tile.
Yeah.
Okay,
Yes.
and then at the end we will have a certain number of tiles that are flipped on.
So we need to keep track of basically tile state as we go through them.
So my idea was we take the line, we convert every instruction in a tuple of directions. We sum all the direction together and we pack them. At the end, we have one coordinate per line with that can be like, I don't know, 80, one coordinate every line of this file. At that point, we have a set. If the coordinate is in the set, if the coordinate is not in the set, we put in the set. If the coordinate is in the set, we remove it from the set. And the set that we have is the list of black tiles.
Oh, yeah.
So in the end, part one is length of this set is our answer.
Tommaso has a question. I think you just replied to it, but just to make sure we state it clearly. I suppose that means, is the last tile flipped into black? I suppose that means if the last tile was not there, yes, otherwise will be removed, which means flipped back into white.
Yeah. So you have commands for every line. You start from 0, 0, you find the tile that you have to flip. If it is not in the set, we put it in the set. If it is in the set, we remove it from the set. So we change the state, basically like a bit, 0, 1, 0, 1. But we do this with a set because we have an infinite space to handle, so we can't allocate an array because it's infinite, so you don't know the size. And also probably will be sparse, will not be dense. So it's better for memory allocation and stuff like that. So if we want to start to do this, like always, we start parsing the input. Right? Rust analyzer started. Oh, sorry. I can leave it here so everybody's happy. So we have to split line by line. We define a class. How do we want to do? We define a parser with a struct.
A quick thing, Tommaso is also saying that this could potentially be made in parallel. And I presume, yeah, it could, because we could just follow each line, right? That's the goal, to follow each line of the instruction and count for each of them.
We can go in parallel through all the lines. Yes. At the end, they have to lock on the set because the set is only one. And when you flip a tile, you have to have a lock on it because I don't know if Rust is already doing that by nature, or at least if it was C, you have to lock on top of the hash map before hash set before accessing it. And yes, we can do this in parallel. Now let's do that sequence.
Yeah, or I suppose the alternative could be that rather than an hash set, you do an hash map with an atomic counter as a value. And then you just keep increasing, and then at the end only count the odd ones.
Right? Yeah, you can also do that. I don't know what is faster in your opinion.
I have no idea, but we hopefully, if we can finish it today, all the exercise, maybe we can try to explore this option. I will go for a simple solution first, as usual.
Yeah. Well, let's start with the parser, because Roberto was asking earlier. So let's start parsing and go from there.
So I suppose we have two options for if we want to do a little bit more idiomatic parsing using any trait. One, we could do a from string, which is the standard. So you just give it the entire input and eventually it's going to give you back a struct. Or because this is nice to do with iteration, I suppose, we could do like a from iterator for chars, I guess. I'm not sure.
We have to split line by line. And then the single line, we have to convert the single line basically to a tuple of coordinates. Every line becomes two numbers, X and Y.
So what we could do, maybe we could do a type that is the coordinates, I guess. and then we can do a from string on that one.
Okay. How do we do this? Tell me.
So you can create your own struct that contains 2 values. So call it, I don't know,
point.
Cell or point, yeah, whatever. Tile, yeah, maybe
Hexagon. Yeah, tile makes sense.
Yeah, this is this contains x and y. We can. Do you want to do them as tuple or separate values?
As you wish. The difference is that then when you access, you have item.x rather than item.0 and 1.
I think is
so this is a little bit more expressive, yeah.
Also, they must be signed because they can go negative. Now we have to implement the from string.
Yes, so from str for tile. And you need to import something, but it should tell you, I hope.
If it's working, yeah. Yeah, there you go.
Okay. So if you click on the bulb, it will add import, and then you need to specify the error type and a function. So implement missing members will give you a template.
Sorry.
So type error equal, we can keep it. No, you need to leave error equal, and we can keep it empty for now, just to keep it simple. And then here we implement all the logic, and at the end we need to return an OK with a new tile.
Okay, so now S will be the single line.
Yes.
So S will have chars.
Yep.
Okay.
Now, do we need to read the chars 2 by 2, right?
No, 1 by 1, because east and west are long one. If we find S or north, we have to read another additional character.
Okay.
Right, yeah.
Yeah, that's the final function that helps us with this. That's so every tile get. I think just a moment. Let's implement a tile parser that contain chars that is of type chars. This is not happy. Okay, I have to import probably chars from somewhere.
Chars, you mean like the iterator of characters? Okay.
Yeah.
So you probably have to deal with lifetimes there, right?
It wants us to deal with lifetime.
So you need a tick A, and also in the struct you probably need the same, yeah.
Okay. So now for this guy, how do we implement a new? I don't remember how to implement new.
So implement tile parser.
Tile parser.
And you need to give it also the
lifetime.
I think you can use even an empty lifetime, so underscore there.
Okay, new.
And now new, it's whatever you want to receive as input, and it returns self.
I want a chars iterator. It returns self with a lower E. I don't know why I throw double capitals today. And now I return. Yeah, my end is lower than one end is lower than the other. This must be mutable, probably, because we are iterating over it.
Yes, probably yes.
You can define it as a mutable.
Yeah.
Reference when you get it, maybe.
I think it depends if you want to take ownership of it.
Well, we do, right? As in, we're not planning on giving it back.
No, I'm not planning on give it back to anybody.
Then don't put the mute, because mute then will be the tile parser when you initialize it, and then by consequence of that, every member will be mutable.
So now it's complaining that I'm returning cannot infer an appropriate lifetime for lifetime due to conflict requirements, except...
That's interesting. Okay, try to do another thing. Try to do tick A, but also you need to copy that in just after implement. And now, you need to say there that this is yes. Yeah.
Okay. Yeah, everything is lifetime A. Everything. Okay.
And this will be the same lifetime of our input data, because at the end we are reading from the same input string.
Okay. Now I want to be able to iterate on top of the tile parser, so I have to implement iterator for
tile parser.
Tile parser. Let's deal with lifetimes later.
Probably will complain, yeah. But I think you can do the same as above. So you put the A just after implement and just after tile parser.
Yeah, let's see what it tells us. Here it's not going to tell me that I have to implement stuff. Okay, yeah, because I don't have to write them.
Put the lifetimes. I think it will give you a better suggestion. Oh no, it did work anyway.
And now it's complaining probably. Yeah, lifetimes. So let's try again with this. This.
After impl. Oh, let's see if that works. That would be nice.
Okay. This time, what we want to return from every line, we have to return a tile.
Yeah.
Okay, so you can just tell it tile, I suppose.
I don't know. I have to specify a different way. Okay, this is returning an optional self item, so it's returning an optional tile. I think it's already fine like that. Now, what we have to do, we have to match the self chars next. If this is a ist, let's go with the easy stuff. If it is an ist, we have to return a tile. No, so yes, we have to return a tile with an X of no, again, sorry, I'm getting lost.
East is 1.
This is the parser, it's not the final one. Sorry, a moment. I'm getting lost a moment.
Yeah, I suppose we are not entirely sure we'll always have like with one character that we have a result, right?
Yeah. Let's do this for now, and then with some... I also have to put some here, because next I give you an optional, I think, right? What we said before, if we go east, we go choose 0. If we go west, we go minus choose 0. If we go north, we return
we need to read the next one, right?
The next character. So we match again this guy. So we copy, paste.
Oh, nested matches.
Oh.
And on this guy, we can have northeast, or northeast is 1, because we're going east. North is going minus 1. Okay, so it's minus 1 because north is negative for us and south is positive. Well, to be honest, we can do also the other way around, but let's just
doesn't matter.
Also, we have to say that for everything else, we return
which will basically stop the iteration at this point.
Yeah, because there is an error in the input, or it's better to panic or doing something like...
I mean, we have never been dealing with errors in a sophisticated way, so this is probably fine for now.
And now
there is a question from Tommaso saying, is this component returns... Oh, sorry, this was the start of the question. We need to keep the current tile, or this component returns just the +1 and similar in order to collect them after? I think, yeah.
We collected them after. This is the tile parser that give us a sequence of commands. Then there will be the this tile parser, the from string on the tile, that will take the S, that is our from string, iterate over them, fold, reduce, how it is in Rust, and then at
Fold,
that point we create the tile object and we return it.
Exactly, yeah. Yeah, I wonder if we could also use from iterator and do a collect, but we'll discuss that later. I don't want to confuse anyone.
Okay, so now here we have our tile parser new. So tile
Tommaso
parser
says they are commands, not tiles, which is actually correct, because this is a command parser.
Actually, yeah, good suggestion. I like it.
Yeah.
So I command parse my S dot chars, cool. At that point, we must have a sequence of coordinates. We have to sum them together. So we fold. So let. Can I do this in Rust?
Yes, I think.
I think so. I think we've done this before, actually.
Oh yeah, sorry. Oh, the init value is 0, 0. Is the tile that we start from. So origin. Then we have a function with an accumulator and a current value that are tuple of integers. Oh, it's getting everything.
Nice.
And we have to return a new tuple with accumulator 0 plus current 0, comma, accumulator 1 plus, not 1, plus current 1. Everything
Seems
save.
right.
Yes, sorry.
And now you need to return an
now
okay or an error.
Return, okay, tile xy, just this, because they are called xy even in our object. Oh, yeah.
Did you use curly braces?
Yes.
Yes, perfect.
Wonderful.
So now, for every line, I don't remember how to do that.
You can use a regular for if you want. If it
for
makes it
line in
input dot lines.
Lines. It's not Python. We have to prepare an HashSet where we have to flip the stuff. So let mut
block tiles
space
floor.
Yeah.
How would they call it in the README? Sorry, lobby.
Specific floor.
I like it.
That is a hash
set of tile, right?
Tile. Yeah, exactly.
By the way, you can use default with uppercase. Column default.
No, new default. Like this, but I have to define.
You have to spell it right. Yeah.
And probably you'll need to import HashSet unless it did it automatically.
It probably.
It imported automatically. Nice. Okay, never used. Give us a moment. So for every line, we have to let the tile equal. Now we can say line.parse if I specify that I want the type tile.
Yes, you need to also unwrap.
Yeah, because we're returning an okay there.
True. Okay, now we have the tile. If our lobby dot contains tile.
Tommaso is also asking why Rust doesn't force us to implement partially Q and hash.
Yeah, and I replied, wait for it. I think when you do the insert, it's gonna complain.
Okay. Yeah. So we'll complain in a moment.
It's probably
insert or add insert.
It's probably complaining as we speak, and that's why tile is underscored.
Yeah, I think so. So that's an easy one. We can derive. So you just need to do hashtag, square brackets. No, inside square brackets. Sorry, hashtag square brackets derive, and then open parentheses and say hash. I think you also need EQ.
I
and
think it's a
partial EQ.
lowercase as
Yeah,
well.
that's the one. No, it's this way.
Okay, sorry.
Now, why still complaining?
Borrowing. We have to give the reference to it, not it.
By the way, I don't know if it's nicer, but another alternative could be, because when you do insert, it's going to return true or false, depending on if it was there or not. If it's really inserted, it's going to be true. If it was there already, it's going to be false. Maybe we can always insert, and then based on that true or false, we remove.
Yeah.
So when it's true, sorry?
When it's true, it means that it was inserted for the first time for real. Like, was not there and it was
okay.
added.
So if it was not really inserted, I remove it. Here it's
remove.
complaining because?
No, because we gave ownership on insert.
Just put the ampersand, I think.
Now, but now the type is wrong.
Right.
Yeah.
Then no, we cannot do this. You will need to clone, and it's no, doesn't make sense. Let's
By
do
clone. Let's try to see if it's contained. If it's there, we remove it. Otherwise, we insert it, and then we have the number of tiles left.
Sounds good.
Let's try.
Run it.
Okay, sorry. First time in a while that I run. I did
so bets are taken. Is it gonna work? Yes,
I did
yes.
I did a Rust update before, so probably now it has to download the new dependency again. So sorry. I go for a coffee in the meanwhile. No. Yeah, part one. Okay,
I won. Nice. What did I win?
Nothing. Congratulations. A round of applause.
Coins. 10 Luciano coins.
Yeah.
Yay. So now let's read part 2. Okay, part 2. Now the floor in the lobby is meant to be living art exhibit. Oh my god. Every day the tiles are flipped according to the following rule. Any black tiles with 0 or more than 2 black tiles immediately adjacent are flipped to white. Any white tile with exactly 2 black tiles immediately adjacent to it will be flipped to black. So this is a game of life.
I was going to say this sounds a lot like Game of Life, but with hexagons.
they really like Game of Life when they do Advent of Code.
Immediate addition means the 6 tiles that are touching it. Okay, the rules are applied simultaneously and so on. In the above example, this after executing the process for a total of 100 times, there should be 2,208 black tiles facing up. How many tiles are facing black after 100 days with our input? So we have to do the same in part 2 that we did in part 1 to get the starting point. That is our starting grid, our lobby. Is our starting. So we can see if we can do a better way of parsing this later. Now,
I suppose later what we could do is a dedicated struct to manage the lobby, like a lobby struct. And that lobby could even be an iterator itself. So every time we iterate, we cycle a new day.
Do we want to do this now? Or
I think it's going to be easy to refactor. Let's make it work first.
We can just write the logic into a function.
Because the logic
that can become a method,
Okay, so now for 100 times,
we can even make the lobby be an iterator. We can just call next on it for however many times we want.
Okay, then let's do it now. It's not that difficult, right?
Okay, so let's start with the struct. Normally, how do you structure the code in Rust? Well, let's do this.
Probably better than we usually do.
Lobby. It is containing a lobby that is an HashSet, and the type is this one.
Do we want to call it tiles, maybe?
Yeah, to be
Because
fair,
lobby sounds a bit me.
or you can just wrap it like as with parentheses rather than curly braces, and then use .0. I mean, whatever you prefer. Tiles is fine.
Let's go with tiles. Now we have to implement from it. No, what do we have to implement here to make nth 100?
Iterator.
Iterator
For lobby.
So okay, like here. Okay, iterator for lobby.
Yeah, pretty much the same approach. The only difference is that we don't necessarily have to, like, we can decide what to return. For instance, we could decide to return the number of black tiles every iteration.
Let me see, what is our output? Is the number of black tiles? Yes, I think the number of black
that could
tiles.
be convenient. So you can just say a usides will do. And then every time we call next, we are just mutating the object itself, basically.
Okay. But we have to create a new HashSet with the new tiles because
do we?
Because it's simultaneous. Like the game of life is always the same.
Oh, yes. You cannot mutate your own
you can't
state.
You can't work in place, basically.
You're right.
Yeah, but because we have that tiles, we basically swap at the end our own internal tiles.
Yeah, so we have a let mutable new lobby. It is a HashSet default, and the usual stuff. So now this is an infinite space. So the tiles that we have to take in account are all the tiles that we have plus all the neighbor tiles that we have in our.
Oh yeah, we did something similar.
Yes, we did something similar.
In 3D, 4D, yeah.
Let to
Can we just copy that?
If you want, we can go and see.
No, I was just joking. Let's do it.
They want to check are the same tiles that we have. So our self tiles. Yes, self tiles plus. Here we can make a copy. How can we copy it?
You can clone, I guess.
Clone. And now we have to implement the trait to be clonable.
Oh yeah, you need to make it clonable, the tile itself.
The tile.
You just add clone there.
To the derives.
So top.
Tile. Okay, sorry, it was.
Go to the tiles. Yeah, there.
What is this? What is complaint?
Oh, maybe it was a wrong import. I don't think we need it.
I don't know why it's there. It's doing stuff automatically.
Nope.
No, was used there.
That's fine.
No, we are right.
Yeah, cool.
We are fine. Okay. Now, for all the tile in our self tiles, we have to add all the neighbors to check. To check dot insert. Yes. And here we have to provide a tile. It will be X and Y. Probably we need something to get all the neighbors of the tile, because this will be tile.x. Let's write it some stupid stuff for now. I have to insert 6 tiles here.
Yeah.
Yes. Yeah, we could have an array, a static array with relative coordinates, and use that to generate neighbors.
The x, the y, that is delta x and delta y. How you do that?
You can just use the square brackets if you want, but we could. Yeah, let's do that first, and then we can move basically this entire array to a const.
Yeah.
Okay, let me just write it before I forget what to write.
Do.
Yeah, just I suppose as a reminder.
Oops.
These are hexagonal tiles, so they will have 6 neighbors. So.
I wrote 6 of them, I think.
Oh yeah, nice suggestion by Tommaso. We can also implement addition for tile, so we could basically say a tile plus another.
Yeah, that'd be cool. Yeah.
Or we can implement addition for a tile to a tuple of dx.
Yeah, a couple of integers and.
Because you can also sum different types if you want to.
Mm-hmm. Well, for now, I guess. Ooh.
Yeah, no, this is fine. I mean, we can do it later.
Here we have to return an okay. What is this?
Sum. You need to return a sum.
Sum, and this will be the len of the new lobby. So
yes,
new lobby.len. Okay, so now it's stopping complaining.
And let's also remember to do self.lobby equal new lobby.
Yes.
Before we do that.
Tiles.
Tiles, you're right. Sorry.
Yep.
New lobby. Okay, we are terrible with names, but
Sorry.
do.
I suggested the name. My bad.
No, we could just rename new lobby to new tiles, and that would probably be, I suppose, already good enough.
Fair.
We are complaining about
mutable reference.
Mutable. How do we make it mutable?
What needs to be mutable? Wait. Cannot move self tiles. Oh, yeah, you can use a reference there. Yeah, that should do it.
Now, this dy is if intentional prefix. Yes, no, it was not intentional. I made a typo.
This is a very good catch. Thank you, Clippy.
Yeah, thank you, Clippy. So now we have all our neighbors. Now we have to process the rule for what
tile and to check, I guess.
Yeah, tile in to check. Sorry, I was looking at what was the type of to check. I got a moment lost there.
We must check it.
We have to check how.
We have to count the neighbors, right?
Yes, we have to count the neighbors. Then the rules are here. If it's black, if it's white, and there are exactly 2 neighbors. Okay. Let's count the neighbors. First one. Do you want to do function for this?
We could probably do a function inside the lobby itself, I guess.
I wrote neighbors correctly. I have no idea. Self.
Looks right.
Source of a tile, but now we have to send a reference because we don't want to consume it.
Yeah, good one.
Okay, let's implement this function. Are we implementing something for lobby? No. So implement lobby function neighbors that take a self of type self. I have to specify the type here, or is not needed?
It's not needed, and you need to say reference to self. Otherwise, you can call this method only once.
Okay, and it's giving us back a usize.
No. Sorry. You just need to say ampersand self, all lowercase, without type.
Without type.
And it's getting a second argument though as well.
By the way, Tommaso has a good question because I think this can be a little bit confusing. So why not to tile directly? I think to tile directly, we can implement the generic neighbors, like the 6 tiles around a given tile. In this case, what we want to count is the ones that are black in the neighbors. So maybe we can call it black neighbors or something like that. So we need to know exactly what's already in the HashSet and count the neighbors that are already in the HashSet.
Yeah.
Makes sense?
This is...
Are we arguing about the naming of the function? No, sorry,
no, I think Tommaso was suggesting why, rather than implementing this method in lobby, why didn't we implement it directly in tile?
Because the tile has not the concept of the lobby. So
exactly, because we want to count the black neighbors in the lobby, not just get the list of neighbors around a given tile.
A method
basically
that you can get from the tile is the coordinates of the
neighbors.
Then
yes,
you have to see if they are or not in the lobby, but
Yep.
we can do this refactor later. I mean,
yeah, that could be maybe a better name. We can probably find a shorter one, but yeah, that will be more expressive, I guess.
Yeah.
Or count black neighbors, something like that.
And flipped neighbors.
okay.
I don't think we ever specified that it's color or anything.
Let's rename them later.
Yeah, okay, whatever. They're the only neighbors we care about for now, so.
It's a bit confusing between generic neighbors of a tile as relative points and neighbors that are actually active in the set.
Yeah.
Yeah.
So I think it's a very good question, but yeah, hopefully now we clarified what we mean.
Mm-hmm. Sorry.
If self.tiles.contains neighbor tile, at that point, this can be done for sure in a more rusty way. That's the. Oh, this is not that one. Because I have to do a reference to this guy, not.
Yes.
So this can be done for sure in a better way. And also, I'm replicating this loop, so this can become a constant. Again, refactor. So now this must give us the number of neighbor in theory.
Is it not getting the neighbors as an argument, though? Like,
sorry,
are we not creating these neighbors in that to check thing?
Yes, but these are again two different things. The neighbors of any given point in the set are the points we need to consider. That
plus the points in the set. Plus them.
Then for every one of these points, we need to count the neighbors and decide, are they going to become active or die out or be removed?
And now we have to do this logic.
So, apologies, I'm lost as well.
Basically, if it is black with 0 or more than 2, they become white, so we don't have to add them. We have to add them to the new lobby if they are white and exactly 2, or if they are black at that point. If they have exactly 2 neighbors, they are black in any case, even if they were black or they were white.
They stay the same. Yes.
Yeah, they go black, and they never come back. No, joking.
By the way, for us, black means they are in the set, right?
Yeah, they are in the set. Black means they are in the set. White means they are not in the set. And instead, if they are black and the neighbors are 1, that is the other condition, they go black. So let's try to do this reduced logic. So if n neighbors is equal to, or n neighbors is equal to 1, and self.tiles.contains the current tile. At this point, the new tiles not append insert
yeah,
the tile. Now it's complaining because I have additional round brackets. Sorry, too many languages. And now here is complaining because borrowed value new tiles. Here when here we assign and
yeah, you can return self.tiles, I guess.
Oh yes, good point.
Yeah.
Self.tiles.
Because we changed
you took ownership in the struct. Yeah.
Now, at this point, after all of this, here we have our
Would it make
lobby.
sense to do something like this? Like to do a match self-tiles contains and then true or false? Probably not, because we care only about that one branch, right?
Yeah.
When it is true.
Mm-hmm.
Like we wouldn't really have anything in the false.
Yeah, because is white. We don't put it in the set.
Okay.
Done. or if he's wrong, we have to review this logic, but I think he's correct. Is the nth, or you have to do dot iter?
No, it's already an iterator itself because it's implementing iterator. So you can do nth, I think.
No, well, we have the lobby. We have to use the lobby.
But in the lobby, yes,
Yeah.
in the lobby object.
So we have to
So
do
is
the
it not a lobby?
guy. No, lobby is an HashSet of tiles. We have to create the lobby.
We have to make it
with tiles.
Yeah, we can do an helper, I suppose, to move all that logic above to. Are you changing part 1 or part 2?
Oh, yeah, you're changing part 1.
I never do that. No. Okay.
Must have been somebody else.
Self-touch. Part 1 is still fine. Okay. Part 1 is fine. Sorry, guys. I touched the wrong file, the wrong piece. But for me, it's a constant to do the stuff in the wrong function. Copy and paste, I modify the old one, not the new one.
You need to use curly braces.
Yeah.
Oh, let's see if you can do this. I don't know if you can call a method direct. Maybe you need to put parentheses in around it. No. Sorry, parentheses around lobby and curly braces.
No. I think it's just complaining that I was not unwrapping.
Okay.
Yep.
I didn't know you could initialize a struct and start to call methods on it. I thought you needed either parentheses or to assign it first. That's good.
Now we can have an off by one error. I mean, is 100 days. And we start on the first one. So we do 99 steps, to be honest. We are not doing 100 steps. So I think here we need a 99.
Based on that example, yeah, it looks like.
Yeah, because, okay, let's try. If it's not, I will put a 100.
Ooh.
Okay.
This is going to take some time. Nice.
Hey,
good job.
Nice. And 99 was correct.
Almost and off by 1 error. Nice catch.
Yeah,
okay,
because we have to do 99 jumps because we already start on day 1 and they want the result in day 100, not after 100 days. That will be day 101.
Yeah.
Okay, so I suppose we could remove that duplication there.
Yes.
Right?
Okay, here, how can we do that? We can create on the tile a method to give us the coordinate of all the neighbors.
Yep, it can literally return that.
Let's start to do that.
We can define that as a constant somewhere, and it just returns that. And
you can do that at the top, I think, at the top of the file for it. And just say const and I don't know, delta neighbors or whatever.
Deltas. I can create them like this, or is going to complain?
Yes, you just need to give it the type because everything outside a function requires.
This is an array of E32 of size 6.
Can you give it an underscore? I'm just curious if it's going to infer.
An underscore?
No. Okay. It never infers anything outside function. That's interesting.
And now it's
on. You never use deltas. Yeah. Give me a moment.
You will not.
Then we said on the tile we implement a tile somewhere. Implement a tile.
Should be.
No, we started to implement tile. We don't have implement a tile, and we started to have it. There is implement str for tile. So here I go with implement tile, and we do impl fun. Neighbors that is taking a self and is
reference.
A reference.
Oh yes, otherwise you take ownership.
And is giving back 6 tiles.
Oh yeah, you can just allocate them in an array. Yeah, tile semicolon 6.
We give back 6 tiles. So let mut return value that is of type tile of 6. We have to initialize it somehow.
Oh, that's gonna be painful now if you do this. Yeah, Unless you implement default for tile, then you can do it easily. So if you derive the trait default, you can just say default at the end.
Can't we do this?
Or, yeah, which is basically the same thing.
Here, why is complaining?
We're not returning that.
We are do ret.
Okay, now we have to.
Now why is still complaining? Copy is not. Oh yeah, because okay, I'll tell you why. Because when you do that semicolon 6, that basically literally means to the compiler, take this object and copy it 6 times in a row.
Okay, so tile must implement
Clone. But it does.
But do we want to copy that item 6 times in a row, though?
Okay, let's try something else. What if you derive default for tile? So you also add the default there with uppercase D.
Not in the bug.
Which basically means it's going to look at all the attributes of this trait. If they are all default, which I32 are.
Now I have to give it...
Okay, now try default. Let's see if that works better.
Yeah, but
if
what
it
I
doesn't
go...
require
ret L. Yeah.
Yeah, ret colon. Okay, now we are not mutating it. Give us a moment.
Okay.
Yeah, we'll get to that point.
Yeah, because the alternative, and Tommaso is suggesting that as well, would have been to say like tile 0, 0, 6 times, like copy pasting that 6 times in a row.
Yeah. Now for our coordinate displacement in delta and an enumerate of it, so dot iter dot enumerate. I also want the index. How can we do that in a nice way?
Dot either, I guess, dot enumerate, right? Now you need to do a double parenthesis. Yeah, exactly.
So now I have, okay, perfect. Here inside I do ret of I equal to tile of x is self.x plus my displacement. Same for y. And, okay, and this is our neighbor list in the tiles. The function is never called. Yes.
Yeah, well, one interesting thing is that we could have used a map, but then when you need to collect into an array, as far as I know, you cannot really do it directly because it cannot be dynamically sized. Like you need to match exactly the numbers that are there. So there is another thing that is called like, I think try collect or something like that. Or try into maybe you can use. But it's it gets more complicated, so I like your approach. But if that was a vec, for instance, we could have just done a map and a collect.
So now for all the neighbor tiles in the tile neighbors, we do check insert the neighbor tile, and we can get rid of these
all
in
the
theory.
stuff. We saved one line.
I comment because conservative, I never know. So now to check taking the tile for all the tile that are neighbor, put them in. Cool. Is this still working? Are tests still green? No, because no, it's a warning. Okay, test are green. It wants deltas all capital.
And actually, Thomas is suggesting something really interesting as well. He's saying instead of using const, can we use static? And the difference that const is literally the compiler copy pasting for us everywhere, while static is allocating only once and then referencing that one global allocation.
Okay, but well, in our case, we are using it twice, and they are 12 numbers. So
we're not using it twice.
No.
Well, we're asking for these for every tile, right?
Yeah, I think so.
Well, we are. is copy and pasting where we write deltas. So
it's still going to end up in the stack anyway, right?
Yeah.
Yeah.
But in any case, let's do that with const, then we can...
Yeah, we can look at it later. Let's have it working again, because you didn't commit, right, when it was working.
Okay, let me commit.
Well, is it working now, though?
Yeah, it's okay. The tests are okay. It was just complaining that deltas must be uppercase, but it's working. It's not...
It's fine. It's not gonna... Yeah.
It's a style thingy.
Yeah. Let's do this.
It doesn't know.
Copy and paste here is not super fancy. I'm lazy.
If it compiles, we can deliver. Yeah, exactly.
Guy. Back here, we are using that stuff. Okay, we can get rid of this commented code because it's working. Now, we are doing that in the neighbors. There is this neighbors, and here we are still using deltas. And again, here we can do for n tile in tile dot neighbors. And we just, if it's this can be this point simplified, if contains ret. So now here we, so let's see if it works. Run.
Is it getting slower?
Benchmarks later. It's still working. Now, probably here I feel that we can do something smart. Because we can return tiles neighbor dot filter.
Maybe.
We can filter the one that are contained.
And then just do a count.
Filter, no? Or I have to do iter before filter.
Neighbors
is an array.
Yeah, then you need to do iter.
Okay, X is a tile double pointer to a tile.
Oh.
Doesn't really matter, I think. We'll see.
Tiles contains. So give me only the one that contains tile.
To be honest, you can also use into iter, I think.
Now to count them.
Length.
Dot length. Or dot count. Dot count because it's an iterator.
Yeah, it's an iterator because dot length was farting.
No, it's still not happy.
Doesn't like that contains or what? Okay, no, it was just
happy now.
Just give Creepy a moment, guys. So
okay,
neighbors are the neighbors. I iter filter only the one that I contain and count them. Okay.
It's not super fast, this one.
No.
I mean, 4 seconds is not too bad, but yeah, I guess we are doing a lot of stuff anyway, right?
It's doing a lot of stuff with sets. I probably can think on some data structure that is faster, but still we have to create a new grid that we can't work in place again. So same reason as before. Working in place is not going to work for a game of life. Any other optimization? No, I think at this point is quite... There is this code that is the initial state.
Oh yeah, this one. We can create like a new in the lobby itself.
Do you commit before that though? Because we have it running now, right?
Yes.
Sorry.
Eugen is the Git police.
Yeah, exactly. But did you commit today?
You're gonna get a nice bonus, Robert. Lots of commits.
Okay. Now we can implement a new from the lobby, right?
There is an interesting suggestion here that if we change that last .iter that we wrote, into either. Remember the double reference?
Yeah.
Mm-hmm.
I think in that line 79, when you do dot contains, it's gonna automatically dereference for us, which probably means that duplicates a pointer for nothing. I mean, it copies the pointer, so into either will give you directly a reference, so that should be a little bit more efficient. That's a very good suggestion.
Nice.
I don't know if practically we save a lot, but it's an interesting thing to discuss.
Do we want to implement in lobby a from string? Or do we want to implement a new? So basically, from this string, we can go to a lobby.
Yeah, probably we can do that. And then it becomes one liner above and the other one as well.
Yeah. But it's better to use a new. It's better to use a from string.
I think from string is a little bit more common from what I've seen, because then we can do let lobby column lobby equal input.parse.unwrap.
So if we do parse this turbo fish in a lobby, and then we go and so something, yeah, also some round brackets every now and then. So something like this, input parse that as a lobby, go 99 step, unwrap.
Yeah.
Yes, okay.
No.
I don't know, by the way, if parse works in that turbofish way. I guess we'll figure it out when we implement the from string.
Is not okay. Now it's not implemented because
no, but I don't know if you can do it. Let's see. I'm curious.
Now implement.
I'm also very curious what MAB means.
STR. Sorry.
There in the comments, Tommaso said MAB, and I was hoping
I think it was just
gonna clarify it. Ah, okay, just typing. Sorry. And I thought it's something the cool kids say we could have learned.
So now our logic is this guy. Let's just copy and paste like crazy for a moment. Now we have to. Oh, sorry. Now we have here to return a lobby that contains tiles. These are tiles. And also those are tiles. Ctrl G. There. This is our S. And here is complaining about.
I think it wants
okay.
to wrap it in an okay, yeah, because it's
yes, because it potentially the parsing will fail. Like we are not caring because we know the input is good, but potentially, I mean, technically we should handle errors there.
So now we can go here, remove all of this in theory.
Yeah.
Let's see if that parse works this way.
It's not happy with end now. Because it's a result, you gotta unwrap the parse, yeah. Makes sense.
Oh yeah, dot unwrap dot end, yeah. Unwarp.
It's like Star Trek, unwarp. You go warp velocity, but behind on the back. Warp -9 stuff.
It did work, that parse. Cool. Nice.
Cool. So part 1 can become a one-liner too.
Wonderful.
The only difference is that we need to do
the length.
Dot tiles dot len.
Oh yeah, correct.
Yeah.
Right.
Tiles, yes, or yeah, because we want the len of the tiles. So lobby parse as a lobby, unwrap it, give me the tiles, give me the len.
Although the lobby itself returns length, right?
Yes, but not when you create it after the first iteration, but you have the length of the second day, not of the first.
Oh yeah, correct.
But in any case, still one-liner, guys.
End of 0.
So take a string, parse it as a lobby, unwrap because I'm wrapping. Tiles, len, or do 99 step, unwrap and give me the result.
Unwrap because Rust.
Yes, unwrap because Rust. So to make Eugen happy,
Thank you.
Make Roberto lazy.
More refactor, okay.
Refactor, more refactor, super refactor.
All the refactor, yeah.
I'm curious. I mean, we are almost. I mean, we are more than at time, so probably good time to close. But I just want to show you a suggestion that could be cool. If we run the bench, maybe switching the to branch of if on tails.contains allows CPU prefetch the instruction. I have no idea what that means. But
yeah, it's the no branching movement. Every time you do a conditional, like an if else, and there's two branches, the computer kind of assumes one of the paths which it's likely to take, so it prefetches the instructions, so it could move quicker. But if it gets it wrong, it has to unload everything that it prefetched and fetch again. So, but I don't know. In this case,
contains, so it means in line 91, we were saying.
But what I will do is to run the bench first, then do the change and see the difference, right?
Yeah, it makes sense.
Because this could be very subtle or also very big, I don't know.
Yeah, I think.
But if you run the bench, will run in whatever optimized mode, right?
Yeah.
Okay, let's run them like it is.
Bunch.
I can't type today.
Run a bunch.
It's like a banjo, but different. Sorry. Just got a notification on email that we are live streaming.
Thank you.
Great.
Thanks, Google. Don't worry, Tommaso. It's not something I know too much about either. I just happened to read about it recently, and I'm kind of like, oh, I know what this is.
The prefetching of branches, I think, is there from Pentium.
Yeah, I've not done much code. I've not done much code which is low level enough to run into this kind of stuff. I think Rust is the first language which is more like this, so it's interesting. I'm curious how and if it's gonna affect it.
If the bands are starting.
Yeah, some point today.
Also, part two is quite slow. So let's see. Yeah, 100 iteration because in 21 seconds. So take it easy, guys.
No rush. We can come together. Sorry.
Let's count with me, but in binary. Yeah.
That would actually be something. Let's count to 21.
Okay, now the suggestion was, if I understood it correctly, but Tommaso tell us something if I understood nothing. To do this in the reverse order or what?
No, debranch it basically. As in, instead of there being two branches, just have the one branch. So if it prefetches, it will only prefetch the correct instructions, if that makes sense. So basically find a way to just do the tiles insert, which returns a boolean, and base it on that.
Yeah, but we tried that before, and doing that, the tile is destroyed.
Yeah, you will need to clone the tile.
We might need to clone it, which might mean more allocation. So that's why I was saying I'm curious if it's actually any better or not.
Okay.
Rearrange the instruction, Tommaso says. If not, tiles contains. Yeah, but I don't know if that helps.
If not tile contains, and then switching those. Tommaso, confirm, please.
Yeah, but I'm not sure how it would work, though. As in how it helps.
Because I think the most common instruction was the one discarded. I mean, prefetching is preparing this instruction.
Yeah.
But we were going more often in the else, not in the matched.
Do we know that, though?
Not for sure.
Okay, well, we can try it. You run the bench again, and it'll tell us if it's actually any quicker.
But yeah, this was the suggestion.
All right. Okay, I thought the suggestion was to get rid of the branching altogether.
No, because when you have an if else, the CPU is preparing the if, not the else.
Yeah.
So it's faster to go in the if than go into else. But also we don't know statistically
which one, is more likely. Well, technically, for prefetching, the best thing to do would be to get rid of the branching altogether.
Yes.
Because then anything that's prefetched is 100% valid 100% of the time. So we're not wasting time,
Well, if you enter in the if, yes. Otherwise, it's discarded too. But
true.
The problem with inserting and removing is that the insertion is consuming the noise, not a relevant change.
Yeah.
This can be noise on my machine.
Yeah. Well, if we get a 9099th, maybe it becomes relevant, but
not yet.
Not yet.
Do I have change? No, I don't have change.
No.
I have all those tests.
Cool.
Okay.
Should
we
we?
Done a good job for today.
Yeah, I think so. Good job, Roberto. And thank you, Tommaso, for all the very cool suggestions.
Absolutely.
All right,
Tommaso needs many beers whenever we have the chance.
100%. All right, so I'll say we wrap it up then. And, well, for everybody following us on Twitch, you can find the recording on YouTube. There's a link in the About section on the Twitch description. If you're watching this on YouTube, we're also live streaming this on Monday every evening. Evening for us in Ireland. I should specify that. Make sure to check the Twitch link. It should be in the YouTube description. Give us a follow so that you're notified every time we go live. Feel free to leave us comments or PRs. Luciano, please, can you put a banner of our GitHub repo so people know where to give PRs and comments and to just take a gander?
I was looking for the next step, which is raiding somebody. So.
Fair enough. We will do that in a second. Yeah. So everything's accepted in terms of comments or PRs or forking or whatever else you might want to do. Keep in mind, we're trying to learn. Oh, go ahead.
So no, I just wanted to say that as a comment, we started to do the exercises from this year, but we just wanted to finish the stream from the previous year's one first. But yeah, because we started and we are trying to keep up every day, if you're curious, you can find our solutions in PRs in this repository.
And we plan to discuss the PRs before merging them after next year when we start to do this again. Obviously, on the first exercise that are very simple, we go a little bit faster.
Probably, yeah.
Yeah. Fair enough. All right. Well, on that note, thank you everybody for joining, for watching, for the comments, and for the help. And let's raid somebody.
Yeah, we are going to raid somebody who is doing Advent of Code in Rust for this year.
Oh,
nice.
Enjoy that.
This time is working.
Enjoy the up-to-date one, yeah?
Exactly. Starting the raid in 5 seconds. Bye, everyone.
Let's do this for 5 seconds, guys.
And that was great.